Hey calculus class, I am going to go over this problem on continuity, and this is what we call a piecewise function, meaning it's defined differently in different regions. So below -3 it's always -8, above +3 it's always 13, and in between those two values we get this line. Alright, so let me show you visually what that looks like. So y equals 8 when we are below -3. Let me pull this up so you can see there's the x-axis. So below -3, we're on the line y equals 8. Alright, y equals 13. That's this guy right here when x is above 3. So that's this thing right here, then the purple. And then in between it we get the line y equals ax minus b. And that's a line, and right now a and b aren't known, so they get to vary. So a is slope, and we get this slope that looks like that. Alright, and then we want it to connect these 2 points. So let's say a is 2, and let's move b up. So that didn't work. And then let's rotate that down a little bit more. So we need it to hit both of these. Let me make this go down to like -20. We need it to hit both of these, but hit them exactly. So it's going to be somewhere in this range. So here's the thing. This is going to be a system of equations. And so what we want is when x is -3, if I plug -3 in for this x right here, so a times -3 minus b, I want that to be equal to, right, when x is -3 less than or equal to -3, we get -8. So I need it to be equal to -8. Alright, and then when it's equal to +3, we need this thing to be equal to 13. So when a times +3 minus b, I get +13. So what's going to happen here when you do this is a system of equations, and you solve system of equations by substitution, or in this case when you have opposites. So if you see here, I have a -3 and a +3, both multiplied by a. So when that's the case, what you do is you add these equations together, and I would get -3a plus 3a would be 0 a's. -b minus another b would be -2b. And if I add these together, 13 minus 8 is 5. So b is going to be equal to -5/2 or -2.5. Okay, and then I can plug into either one of these equations for a. So I'm going to clear this off. I know b is -2.5 or -5/2, and I know that a times 3 minus b is 13. I'm just plugging into the bottom one there, the bottom original equation. So that's 3a. I'm just going to rewrite a times 3 is 3a minus b. Well, this is b, 5/2, so minus -5/2 would be plus 5/2 is equal to 13. And now I'm just solving that equation for a. So coming up here, I would get 3a if I subtract 5/2 from both sides. If I move this over and subtract, I would have 3a equals 13 is the same thing as 26/2, and I'm subtracting 5/2, just getting a common denominator. So that's 21/2, and that's 3a is 21/2, and I want 1a, so I divide by 3. So 21/2 divided by 3 is 7/2. So there's my a, 3.5, and my b is -5/2. So I put those values in, and I see that it doesn't look right at all, and it's because I put +8 in here instead of -8. So there's a -8, and now I see that they are connected when I do that. So my fault on the original visual. that should have been the original value right there. And all those different things that we couldn't come up with was because I had the 8 in the wrong place. So anyway, there's the visual of the solution. So 3/2 x minus -2.5 would be like plus 2.5 or 5/2. And there's our line that now connects those two values. And now we have a continuous function. So a is, they want a simplified fraction. They wouldn't take a decimal here. So make sure you're typing in as fractions. So a was 7/2 and b was -5/2.